The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
My name is Rajesh Kasturirangan. I'm one of the co-founders of ClimateX, which is one of the co-sponsors of this event, along with Fossil Free MIT and many, many other organizations on the MIT campus. We also have non-MIT people here, several of whom, some of whom are MIT alums. So Jeff Warren is one of our speakers. Britta Voss, who is on Skype over there, is another speaker. And then we have Nathan Phillips and Audrey Schulman. So we have a really, really fantastic lineup, but let me just explain what we are doing and why. So ClimateX, the idea is to create an open climate learning platform for the whole world, but starting with the MIT community and then broadening that to the greater Boston area. So IAP, as some of you know, is the independent activities period at MIT. And that's the time when we do all kinds of fun things. And there are many, many climate-related courses being offered, which we decided why not bring them under one umbrella and call it the Climate IAP. So if you go to sites.google.com/CliAP, you will see all the courses that are being organized. And in that entire, so that's across the spectrum, everything from climate science to policy to energy negotiations in places like Mexico. So what we are doing here is to say, how can citizens directly take action which is grounded in science? And we have actually some fantastic speakers here today who have contributed to that in many different ways. Our first speaker, who will be introduced by Britta, will be Jeff Warren. And Jeff Warren is one of the founders of Public Lab, which does, you could say, community science around environmental questions, both building the hardware that allows you to sense environmental variables and the discussion and analysis that comes from collecting that data. We have Nathan Phillips and Audrey Schulman, who have done some great work together on gas leaks in the greater Boston area. And those gas leaks will be the focus of not just this session, but also the next three. So we have three more sessions after this one. There's one on the 23rd, which is a data hackathon. So we're going to take a dump of data from Audrey and Nathan, and we're going to do really fantastic things with it. And then if you're really interested in seeing where these gas leaks are, we're going to go on a tour on the 30th across the Cambridge-Somerville area and do some gas sensing on our own. And once that's done, we're going to come back on the 1st of February and say, how do we take this and put it in, make that work for us in the public interest, right? And so generally, I think the flow that we are trying to prototype here in these 4 sessions is that citizens can work with scientists and policymakers and others to directly take charge of the climate challenges that affect them wherever they are. And that by doing so, we can contribute to climate action, but climate action that's grounded in knowledge and not just pure advocacy. So I think that that's a really fantastic new opportunity that did not exist even a few years ago. So I'm really, really happy that we have a wonderful cast of speakers. I'm going to turn it over to Britta Voss to introduce today's session.
Great. All right. Thanks, Rajesh. Can everybody hear me?
Yes.
Okay. So my name is Britta Foss. I'm an MIT alum from 2014. So I just wanted to start off with a sort of a brief overview of kind of our motivation and the idea behind community science. And so we called this session From Community Science to Community Action. And that really gets at sort of the larger motivation for this series of seminars of taking science and putting it to use for people. And it gets at the mission of MIT as an institution of using science for society. I just want to start off really, really broad here and ask the question of what is science even for? Why do we have science? And my interpretation of this is that humans are naturally curious and we want to understand the world around us. And we also have needs. We need food and shelter and transportation. And so science has this double purpose for humanity. It feeds our curiosity, but it also helps us solve problems. And it gives us a process and a framework for addressing both of those issues. And we all know that science is very important in modern society. It's pretty much everywhere you go, from your smartphones to social networking to the systems and the infrastructure that make modern life possible. And although we're all very aware of that, very few people have a direct relationship with science, either by doing it themselves in their day-to-day lives or even the other people in their lives. And so another motivation for this seminar series is that we're looking for an angle that will help us make science more relevant to people, make people care more about science, because it has a very important role in our society. And despite how important science is, we all know that science is often misused and mischaracterized at shockingly high levels of our leadership. When you see people, very prominent people, making comments about scientifically false issues, and even to the point of someone like a US Senator bringing a snowball to the floor of the Senate to prove that climate change is false. So there's obviously a lot that needs to be done to make society more aware of and informed about science. And so how can community science address that? Community science is a way of making science speak for communities. So climate change is probably the best way or the best example of an area of science where community involvement is critical. Because here, for example, you can see the effects of climate change on agriculture affect people's livelihoods, they affect the economy, and people who depend on agriculture, which is not just all of us in the food we eat, but people who make their livelihood off of farming, need to understand how climate change is affecting agricultural productivity from droughts and wildfires and all sorts of issues. And so science can help them with that if it is directly addressing their needs. And there's a few more examples. Climate change is affecting water temperature in rivers, which has effects on migratory fish populations that serve as important cultural and economic bases for Native American populations. Nuisance flooding in cities like Boston, and especially in South Florida, is becoming a big problem for quality of life and economic vitality in a lot of areas. Communities in the Arctic are literally falling into the sea in some places because of thawing permafrost. And then, of course, in northern Alberta, you have tar sands mining that's wiping out the forests and it's dumping lots of toxins into local rivers. And these toxins are going downstream and making First Nations communities sick. And so by producing independent science for those groups, you can help them fight back against these sorts of environmental threats. Communities living downwind of coal-fired power plants similarly are at serious risk of things like mercury contamination, particulate aerosols, and other negative health effects. And so if these communities have tools of science, they might be able to file lawsuits or come to their policymakers and say that they need a certain regulation or policy. And another good example, of course, is fracking, where the local communities, especially if there's wastewater injection going on, might be at risk for groundwater contamination, irregular seismic activity, and lots of other environmental risks. So the motivations for community science would be empowering communities by giving them ownership of their data and responding to their specific needs. And from the perspective of scientists, it increased public awareness and interest in science, which is important to making sure that science is still a part of decision making and that science is supported long term. And also importantly, especially in the context of climate science, is making sure that scientists have access to local knowledge that they might not otherwise be aware of. But of course, there's also challenges. So just like with traditional science, community science needs to ensure that the data is high quality and that it can be used for the purposes that the community needs it. For instance, that it'll hold up in a court of law. These projects need to have long-term support. So if you're looking at a long-term monitoring program, it can be hard to make sure that that's financially viable over the long term. And then the community's needs might change over time if the environmental threats change or if the makeup of the community changes. And so research projects need to be able to respond to that. And I'm sure Jeff can talk more about this, but just a few ideas about what can make community science successful. A few key factors are making data and methods open source, so they're freely available and open for discussion. And similarly, open communication between the community members and the scientists themselves to make sure that everyone is working together and not for their own purposes. And probably the most important thing is making sure that the community is involved from the planning stages and not just brought in later on. And that's basically the key difference between community science and what's usually known as citizen science. And finally, just in terms of the appeal of community science, it's important to encourage creativity, both from scientists and the community members. And I think one of the really important aspects of community science is that it can be a synthesis of tools and ideas from different fields that might not happen naturally in traditional scientific enterprise. So just finally, some examples. There's probably many more out there, but Public Lab, as Rajesh mentioned, you're going to hear from Jeff about pretty soon. And then there's also the Earthworks Community Empowerment Project, which gives these forward-looking infrared cameras to communities that want to monitor air pollutants from local operations such as fracking. And then one I just learned about is called SafeCast, which is in response to the Fukushima nuclear meltdown, which is giving communities scientific tools for monitoring radiation contamination in their communities. So with that, I will turn it over to Jeff to tell you about some more specific tools for community science.
As Britta said, thank you, Britta. I'm one of the founders of Public Lab. There were 7 founders, and I'll get into a little bit about where Public Lab came from, but I really wanted to talk about sort of what makes Public Lab different and what that has to do with some of the topics that we're going to dive into in this course. I titled the talk "Renegotiating Expertise" because I think there's kind of this moment we're in now where people are beginning to be more aware of the mechanisms of expertise and where they are working and where they need improvement. And so I had some thoughts on this, and these are they're preliminary. So I'm eager for the discussion portion of the talk to sort of dive into some of these questions. And also, they're not necessarily right. But I'm going to put them out there, and I'm eager to hear your thoughts. So Public Lab does what we call community science. And this involves supporting community knowledge production, which means creating bridges and shared spaces between formal expertise and community needs. So in the picture above, you can see a group that is on the Gowanus Canal in Brooklyn, which is a Superfund site. It's heavily contaminated with polyaromatic hydrocarbons and raw sewage. I think somewhere in the order of 300 million gallons of raw sewage go into the canal every year, and that's actually part of how the New York sanitary system works. I don't think there are any current plans to change that. That's it functioning properly. But this picture is actually the day after Hurricane Sandy, and folks in the Brooklyn sort of chapter of or sort of local group of Public Lab's an open community, so anyone can join, went out in canoes, as they had done many times before in part of their monitoring of the cleanup, and took a bunch of remarkable images of lots of stuff having been washed into the canal, as well as also some of the infrastructure that's been put in place, like these booms, to prevent pollution from entering the canal. This is next to what is now a Whole Foods. So this boom was actually added in response to previous monitoring by that group of the construction site. And I think folks sometimes misunderstand what public lab is. Like a friend once told me that it's great that we're helping the public to understand science. And I think that is part of it, but that's really not the core function or the core purpose of public lab. I think public lab is different because we focus a lot on the question of who above what. We're not necessarily teaching people about science exclusively. We're trying to negotiate a new relationship between science practice and the public, perhaps a more equitable or mutually beneficial relationship. And that involves a lot of, big, obviously big issues. But I think just through our work in trying to support communities facing pollution, the question of how expertise works, how it functions, comes up a great deal. And that's something we've been sort of receptive to in the, coming from communities we've worked with, and tried to understand deeply. These questions like who builds knowledge, who is it for, who asks the questions, and who understands the answers. These are pretty deep questions, and I doubt we'd be able to unwrap them all like in this session today, but they're pretty fundamental to some of the issues that we're going to talk about later. I think what's key is that we're really trying not only to seek to make science findings accessible, I think that is important, but also its methods, its tools, its structure of participation, and the depth of participation that people have in how science functions. This means both making more accessible on-ramps to make it, I won't necessarily say easier, but I think accessible is a slightly different shade than easier. But it also means challenging what's possible in science practice by leveraging things like peer production, open source, as Britta mentioned, and things like the maker community, which I think is changing our understanding of what technology development and it can do and how it can function. So just for some concretes, you may have heard of Public Lab's balloon mapping project. This is our oldest project, and we developed this technique with a number of communities in the Gulf Coast to monitor the BP oil spill, to take aerial photographs at very high resolution of spill-affected sites before, during, and after the spill. Basically, you just attach a camera to a balloon. I mean, it's easy to say it like that, but there's a lot of little things about it, and how you connect things up with string and rubber bands, and how you archive the data and interpret it. And it really is this whole embodied research project in a community that is primarily made up of non-scientists or non-professional scientists, we'll say. This is a good example. There's a group, two people in a canoe, again on the Gowanus Canal, this time in the middle of the winter. In the box, and it's hard to see with the color on the projector, but this is a large plume of raw sewage that's on the canal. As I mentioned, this happens all the time, so people who live there are really familiar with when and where it happens, how often and what volumes, and they've structured their research project based on their understanding, their deep knowledge of this particular site. And one thing that they discovered, this is not in this picture. Next, later slide, teaser. So we also focus on making your own tools. Now, I wouldn't say this is a prerequisite or an absolutely necessary portion of our work, but it has been a really important part of it. We've managed to engage pretty large numbers of people in constructing tools and experimental setups. For example, papercraft spectrometers, optical range spectrometers built around a webcam, and doing comparative work using different sample preparations and, in some cases, ultraviolet light to induce fluorescence. And so this is just a graph of like how many people have actually built and uploaded data using a spectrometer they built themselves. This graph is, I think, the past 52 weeks, but overall almost 10,000 people, which I think is a pretty interesting. It's an interesting project for us. So. All in all, people come to publiclab.org, they post their work to share it with others, but also to ask for help. These people might be scientists, many of them are, but they're just as likely to be educators, to be hobbyists, and the group we're most interested in serving are those community groups who experience environmental problems firsthand. So I guess it's a big question. Why do it yourself? Why go beyond simply dissemination of science knowledge to the public? And I think there's a bunch of different reasons to this, but this is sort of the crux. In some ways, it's because experts, I think, often have a pretty narrow conception of where the public could become involved. For example, public dissemination of science is part of like most federal grants, right? Like there's some portion of it where you have to communicate your findings. This is an area that people, I think, are making good progress on. But involvement in the design of experiments, in the formulation of research questions, in the interpretation and application of those findings to real-world scenarios, those are often considered outside the scope, sometimes even of science practitioners, but certainly outside the scope of a partnership with a community group facing a challenge or a problem. Of course, I think with the do-it-yourself kits and so forth, the cost barrier is definitely a factor for us. It's hard to get more people involved in performing science, doing science, in understanding science, any of those, unless there's cheaper instrumentation. This is not true for all fields, but it's certainly true for some. But I think really, to answer this question more thoroughly, I think we need to take a few steps back and try to better understand how shared knowledge is produced. Key word there being shared knowledge, not just knowledge that's held by scientists, but knowledge that is commonly held, which I hope is the goal, and how expertise works. So, depressing slide, I know, but this is the New York Times Upshot's sort of meta poll of polls. So they're listing all of the projections of the outcome of the November 8th election. Obviously, there was the data didn't fit the outcome. But I do think it's an interesting case, in part because it has a lot to do with, in my eyes, has a lot to do with how expertise is represented today and how it's communicated. How are projections or predictions made? This isn't representative of that many forms of science, but I think it's a relevant data point. And specifically, why and when people trust these kinds of projections. And I'm not necessarily calling these like wrong. I think there's something really. I'll get into this in a moment. Sorry. So data and its interpretation increasingly drives decision-making in our society. And this is something that happens a little bit outside of the scope of what we typically understand as science practice, but it is an important ramification. And I just want to suggest this. I think you can see how this might become a problem where, not in itself, but where it displaces, where it happens at the cost of a more discursive mode of debate in a democracy. And I really am not saying that we should use democracy to do science. What I'm saying is that there is a relationship between the two that we need to better understand. And I think this could present challenges not only because of possible biases. I mean, there's clear problems with science being paid for in certain spheres, as well as ideological issues and their relationship with science in Congress, as was mentioned earlier. But I think also it has to do with some of the areas that Public Lab is focusing on, which may be the most subjective parts of science, the selection of problems and questions to pursue, and of course the application of science's findings. These are sometimes outside the scope. Please.
I don't want to derail us, but
no, please.
You say there data and its interpretation increasingly drives decision-making in our society. I think there's a common belief that, sadly, the opposite is now true.
Oh, so timescales. I mean, last 200 or 300 years.
Yeah, okay.
Sorry. Very, yeah.
But there's
yeah.
So, I mean, one of the reasons I think there's that great concern that we've lost this notion of truth and falsehood.
Absolutely.
In public discourse.
I desperately want to talk about that. I'm being a little roundabout, so I apologize. Yeah, so I mean, as you said, it's concerning when people lose trust. This is a graph of like the 48 hours surrounding the election and the projections of the election's outcome. And it's a really depressing graph to look at for me. I found it really interesting. So this is New York Times Upshot, but I found it very interesting the language that 538.com used, and a lot of other data-driven analysts are increasingly using to tune how they communicate certainty. And this is something where, you know, in the days following the election, you heard some analysts talking about, well, we said it was 70-something% or whatever, and that's actually not very certain. There's something hidden in that, or something that needs to be unwrapped about the communication of certainty, and I think it's a real challenge. I don't know that people have answers to this, but it's something I'm interested in. I know they sometimes would say things like more probable than making a field goal. That didn't help me because I don't know anything about football, but they're trying to communicate what the graphs mean. It's easy to just look and see all blue dots, but it's a very different thing to understand what the ramifications are for how reality plays out. And then, of course, this is the big thing. That sort of scenario plays out on a lot of other narratives, right? Adjacent displays and communications of data. Many of you may have seen this Bloomberg thing. It's very interactive, extremely data dense. Like, there's so many studies and so many data points that have been summarized and meta-summarized to create something which communicates, I think, very effectively about warming trends. If you haven't used it, go and play with it. Like, it's really, really interesting. And so you sort of have to ask, why isn't it persuasive to everybody? Because it's pretty good. And I think it's easy to demonize experts for not being good communicators when things go wrong. I think a lot of complex knowledge is communicated in pretty rich and pretty interactive ways. It's not just learn this by rote,
Is that the name of the tool, compare and contrast?
It's Bloomberg.com, What's Warming the World. And it's a pretty, I think it's pretty great. So I think, with such a wealth of data and such persuasive communication of that data, with all the tools we have today, what is or is something broken about expertise? And I think that in some cases, people are very much afraid that there is something broken. Maybe not about all expertise, but about some portions. Do you have a thought?
Sorry to comment again. I don't think expertise is broken, but I think there's a feeling among experts that no one has the patience or wherewithal to listen.
Yeah.
And when you add that to the conflation and obfuscation of fact by people who really are pure advocates,
Mm-hmm.
and kind of have whatever the interest may be, whether it's to chum up to their party, whether it's to curry favor for a new position,
funding,
some other means,
yeah.
That seems to have overwhelmed the voice of reason and fact. It's just my opinion.
I agree with that. I think the way that I'm using the term expertise here is potentially trying to understand it in a wider scope, which is to say, expertise could be defined as a body of knowledge which is contained or known or collected. But when I mean when I'm using the term here, I'm talking about it as a set of relationships as well. Expertise, yeah, and relationships with experts. And who are experts? How are they identified? How do we trust what they say? How do we, if we are experts, communicate in a trustful manner to people? There's a whole set of issues.
The method was supposed to be the solution to that, but I think everyone's just too.
Well, let's not give up on it yet. No. Yeah, it's true. No, please. And thank you. No, I'm glad you're engaging, because it's something I think about a great deal and have thought about, especially recently. I think so. Harry Collins is not popular in all fields, but he does do a very close and careful examination of different kinds of expertise, and I think it's a very interesting thing to think about. What distinguishes different kinds of expertise, and one in particular that he talks about is meta expertise. And it's the ability to distinguish expertises, the ability to compare and to choose an expert among several who are purporting to be experts. And he says, and I think this is a persuasive point of his, that it's a particularly difficult one, but it's one which many people are called upon to have. It's one that is often based on long-term reputation. It's based on, in some cases, relationships, personal relationships. And it can sometimes be affected by a different kind of expertise, which he calls, I think he calls it downward discrimination expertise, which is essentially the ignoring of one expert because you perceive a different expert to be of a greater authority. So I don't know about every observation he's made, but I do appreciate that the taxonomy he's created and the attempt to understand what are the mechanisms that allow expertise to occur in our society. And I think the question for Public Lab and for some of us is what do we do about the widening gap? Because although there's a tendency to think that the ability to question expertise is driving a wedge, the democratization of knowledge production is an assault on expertise. But I actually think that maybe it's like there's a few other dimensions to that. And although I'm not going to say that's not true in some ways, I think that there are other ways we can think about it as well. So what Public Lab tries to do is to focus on problem definition. So this is the earliest stage in the sort of sequence that might encompass scientific inquiry. And staying close to real world problems. Britta mentioned communicating with people as early as possible, building projects in collaboration with groups that face problems, engaging them in the problem selection, in the formulation of questions, and in some cases in research design. There are specific expertises and capacities to formulate an experiment, but those may be, in some cases, the places where it's most likely that you would learn something from a group that has deep understanding of a particular problem, firsthand knowledge. So I'm really interested in that potential. And in collaborating as much in asking questions as in answering them. But really, like, what are the sources of mistrust? This is I think there are many, but I'm going to try to dig into a few of them. I think one of them is limited ability to evaluate or test. So this affects perhaps climate science more than almost any other type of science, although I guess the LHC is another example. But like, how can people evaluate empirically what climate science is saying? And it's not very possible. You can observationally do it in some cases, but understanding that in a context is difficult. And I mention this one mainly because it underlies a lot of what we do at Public Lab. Public Lab's not primarily interested, or not primarily engaged in climate research. We're primarily engaged in pollution research. But we take it as a powerful thing to be able to empirically verify something, and that's why we're focused on low-cost tools and democratization of the technologies. But this is linked in climate to the following one. Processes are too big to see feedback loop personally. When you go and you do something, it's one of the longest feedback loops that we are confronted with in research. But yeah, oh sorry, I already mentioned this, but basically we do focus on testability at Public Lab on, sort of the question, can you also build this? Do you also get the same result? And this is a picture of one of our spectrometer prototypes. Someone literally tweeted a picture and someone else, and a link to plans, and someone else built one and tweeted that they had, as close as possible reproduced this. Harry Collins talks a lot about the infinite regress, anyway, whatever. I'll get back to it later.
Sorry, is that name Harry Collins?
Harry Collins, yeah. I'll talk a little more about him later too. I should probably start moving a little faster. A couple others. Environmental issues affect someone else. I think this is one where it's not just about. I think there's many sides to that one. It's a tough one, but I think increasingly people are understanding environmental problems as ones which affect people. That's a major step forward, I think. I think the environmental movement had been very closely associated with conservation, and I think conservation is great. But I do think that it is important for people to recognize that there are justice issues at stake with communities that are facing pollution and don't have a way to respond to it, or sometimes even to understand it. But increasingly, pollution is affecting everybody, and the climate is affecting everybody, and I think this is an opportunity for common cause. The other one is one that affects poor communities perhaps more than others, and that's that they have very limited ability to respond, and in many cases to question, and therefore they already have the experience of having been lied to and hurt by industries, and sometimes by the scientists that those industries employ. I know this is a difficult one for all of us, but I think that if you talk to communities who face pollution firsthand, that's a very common experience. And it's unfortunate. Harry Collins actually mentions that he feels that the fact that we are upset when we see that there's been an exchange of money which has influenced the findings of a research project, we are upset because we know that that's wrong, because there's something essential and fundamental about science which is being broken when that happens. So complex, but interesting. So, okay, so what can I do as a scientist or a technologist? These aren't the same thing, but the question might be relevant to both. Tough. We're going to try to get into this. I have some ideas, 4 broad ideas. This is an article which I found very interesting. It actually recaps a lot of ideas which Public Lab has championed over the last 6 years. But it also shows how difficult it is to have an articulate conversation about these things because it is very complex. The subtitle is maybe more important. Experts need to listen to the public. I went into the comments, all right? I know that's not always a productive place to find things, but for once I thought it was really educational. Yeah, so I'll just read it. No, scientists need to do science, not run a PR campaign and become marketing experts. They aren't trained to do that, and it's silly to expect them to. What the rest of us need to do is invest in the school system. Oh, that's interesting, what the rest of us, so John Newman does not identify as a scientist. Is invest in the school system that we've basically let rot in many places so that our citizenry has knowledge of the scientific method beyond a 3rd grade level. If they understand what science is and what it has accomplished, then they'll appreciate its value. It's the job of the public schools to teach us, not career scientists. There's almost too much in that statement for me to peel apart, but we'll try to get to some of these questions as we go. And I'm not putting it up here because I think this person is completely wrong. I'm putting it up here because it's a series of statements that that have some value. I think that it is overlooking other things, but the next 2 are even better. This boils down to wanting scientists to basically add some responsibilities to the number of things they have to do already, yet it doesn't seem to dangle much in the way of tangible money for that extra work. True. TLDR, less science, more photo ops. I think that wasn't a helpful comment, but I think it's reductive in a way that is helpful for us as we're looking at this problem. Okay, so educate yourself. That's what the first commenter is saying, but actually I want to say it to everybody, including scientists and technologists. I think it's really important because we tend to think, and we're taught science often in the public schools, somewhat ahistorically. Where did it come from? How long has it been around? Why does it work this way? And how did it develop into what it is today? I mean, science studies. MIT has a great department of science, technology, and society. Basically, I think it's important not to be naive about this. Understand how the field works empirically as well as theoretically, as in, how do we aspire for it to work versus empirically, how can we measure it to be working or not, or in what ways, who it's benefited and how it developed over time. This is one thing that I do that I really respect folks like Harry Collins for trying to understand, apart from the different ways that people have actually come up with to understand it. I mean, Harry Collins is just one perspective. Part of this, I think, is vocabulary, and just about this particular topic that Public Lab is engaged in. You might have seen 3 different phrases. You come across the 3 phrases to describe closely related ideas. Public Lab uses community science. It's a term that we've helped to define. In part, we've used it because there's actually 2 definitions of citizen science, which are competing and quite confusing. There's 1995, Alan Irwin's definition of citizen science. Rick Bonney describes it as a methodology for engaging a large group of people outside of the science practice in performing data collection and, for example, doing bird counts, submitting data, being an extension of science's ability to interrogate the world. And this is a very powerful thing that I think that Public Lab uses as well. But actually, I think Public Lab is perhaps more inspired by the older definition of citizen science by Irwin. And Irwin described the work of HIV activists in the 90s and earlier who included AIDS patients who were involved in drug trials in early AIDS treatments, and they organized, they protested, they did die-ins at the National Institutes of Health, and ultimately they gained what. And again, I'll reference a term by Collins, interactional expertise, which is that they could read and debate papers and peer-reviewed research. They could challenge the structure of drug trials, and they successfully did so, persuading those who ran the trials to modify how they worked, and in some cases they did so in an extremely disruptive way to the researchers, which is to say they sometimes exchanged the drugs they were given in order to intentionally mix placebos with non-placebos, because they found it to be unethical to do double-blind research on people who are suffering. So it's a complicated story, many sides, many important aspects of this. But what happened was not that scientists per se decided to include people in their research, but that they were persuaded to do so. And they eventually did so, some of them, voluntarily, and collaborated with activists, in some cases, in order to recruit for new trials. So there were constructive collaborations that led out of this sequence of events. And it's a fascinating history. It's a fascinating set of new organizations or new relationships between people who did not originally have almost any kind of expertise besides the immediate expertise of being a victim or a patient, and people who had expertise of the kind that we're more familiar with. So, okay, fascinating and difficult to distinguish the two now that the terminology has been overwritten. So Harry Collins, also Sandra Harding, another controversial figure, but one who I really appreciate. She wrote Whose Science and Whose Knowledge? And she talks about the relationship of feminist epistemology with scientific research. And she just has so much to say. It's amazing. But one thing that I really appreciated was her focus on the selection of problematics, the choosing of scientific questions as an area which, well, as she was writing in the 80s, was understudied, she felt. So she has a lot to say about that. Harry Collins has a book, Are We All Scientific Experts Now? Spoiler alert, no. Definitively he says no, and I'm persuaded by a lot of what he says, but not by all of it. Collins also did a really interesting sort of retrospective of this set of studies from the Chernobyl, after the Chernobyl disaster. He wrote a piece in the early 2000s looking over that work called The Science for the Lambs. He's part of a group of scholars who are very punny. But he looked at how the studies of radiation's effects on sheep in Cumbria and other parts of the UK he worked with Trevor Pinch as well. Basically, it's complicated. But he looked at how researchers trying to map out and quantify radiation did and did not succeed in working with farmers and building bridges between the farmers' knowledge of water flow, of exposure, of site conditions, and of farming practices, and their own expertise to reach conclusions. Tough one, but a really interesting read and a fairly short one. So yeah, Sandra Harding, as I mentioned, who asked the questions which science attempts to answer. I think it's a really important one. I don't know. No, I mean I know, but got to dig into that. So okay. Some tough ones here. The possibility that science as practice today does have blind spots, and specifically when it comes to other forms of knowledge production. Not to say it's not interested, but there are new forms of knowledge, new-ish forms of knowledge production emerging. And I really want to be clear here. I'm absolutely not saying we should try to recognize climate denial. No. That's not the kind of blind spot I'm talking about. I think that's really part of a parallel discussion about the influence of money in politics and science, and it's one I'm not even going to try to broach necessarily in this session. I'm talking about the lived experience of those who suffer from environmental problems, and to some degree the sort of humble recognition of our own limits and unknowns, and especially on critical questions of environmental harm. So number two, in terms of I wanted to tell the story of this picture. That's a sunken boat, so ignore it. This is, I wrote it over with letters, oops. But there's a darker thing here, right? And that's actually melted ice as water came out of a pipe on the side of this canal. And that wasn't on the original engineering surveys, and it wasn't in the EPA's data on this site. But it's an active inflow. There's water and whatever else coming out of it off of a construction site. And it's just a good example of there's a group who lives there. They go by that site every day, and they can do kinds of observations. This is data collection in a way, but they did it not because they were contributing to science in a sort of a noble way, but because they're engaged in the problem, and they're critically monitoring this site, they're watchdogging this site, and they're trying to hold, the abutters, the construction sites, and the potential polluters. They're trying to hold their feet to the flame. They're not objective, but they were able to submit data, including this photograph and others, that updated the understanding of the site and influenced the cleanup. Okay, interesting. And specifically, it's easy to take for granted when you're speaking with your colleagues where your expertise comes from, right? What kind of certainty you're communicating. And this is something that, when people read the so-called ClimateGate emails, it's like insider talk is structured in a certain way. It's hard, it's not designed to communicate to all audiences. But when you are communicating with people, especially outside of the group that you work with immediately, how do people know where your expertise comes from? I think titles, degrees, credentials help here, but they're not the whole story. And there's this really interesting sidebar. The Quechua language group in Peru has this fascinating quality, which is that it has a suffix which indicates the source of your knowledge. So you can say the same thing and indicate grammatically whether you heard it from someone else, whether you experienced it firsthand, and several other forms of empirical context. I often wish that I did a better job at that. Full disclosure, in terms of communicating how you get your expertise, I'm not a scholar of science studies, although I'm a fan of it, as you can tell. I also have no formal science training. I just have some thoughts. I think interactional expertise, what Collins talks about, the ability to speak the language of science, which is on the way to being able to perform science, to actually do science, it's hard to develop. He notes that AIDS activists were able to do so with a lot of hard work. He also ran this interesting experiment, hard to know what to make of it, but where he did a quiz along with a number of gravitational wave researchers, and then showed the answers, his answers, he studied the community for over a decade, but he doesn't do gravitational wave science. And actually a panel was, I think 7 out of 9 of a panel were unable to distinguish his answers from those of practicing gravitational wave scientists. And that wasn't to say that he thinks it's easy. He did this for decades. He worked with these folks for decades to acquire that level of interactional expertise. But what he's trying to say is that there is a fine line of distinction between being able to communicate and critique and interact with people in a field of expertise versus being able to design and perform experiments. And I don't think it's a matter of dumbing things down when we talk about inviting other people into work. I think as the commenter said, scientists aren't necessarily the best at communicating knowledge, but that doesn't mean that they're off the hook necessarily, or that the burden is on exclusively everyone else. I think that there has to be some teamwork here. I'm going to move forward because I think we're running out of time here. I did want to say, let's see. Okay, I know that we often talk about mass communication and so forth, but when outsider groups are more able to challenge or expertise, we're living in an interesting time. I think there are positive and negative ramifications of this. I think that the limitations of science practice, that capacity, budget, some of the things these commenters very clearly articulated, the fact that science isn't suited for every problem we have on Earth. It's not the end all, and it cannot contain all knowledge. But I do think that there are alliances that may be formed. I mentioned the maker community, the hacker community, but also environmental justice groups who have worked for decades to do science, but to do it to answer questions about threats to their own health, to find relationships and between knowledge production and justice, social justice, and who have been doing their own monitoring and watchdogging, often with very good relationships with the researchers who choose to work with them. Again, I think you can look at groups who use aerial photography, as Public Lab does, or Google Street View to investigate pollution issues. There are more empirical means at our disposal today. And I wanted to mention, sort of wrapping things up here, that Public Lab is participating in the Environmental Data Governance Initiative. So Public Lab began as an effort to create an independent record of the BP spill, a separate data set. But with the transition happening, the presidential transition, EDGI is an effort to download and archive EPA data before the transition potentially cuts off access or destroys data, as actually has happened in previous presidential transitions. It's sort of a breakneck effort that's been put together over the past 10 weeks to literally scrape and download everything that the government has online currently. Anyway, I mostly, I don't have anywhere near all the answers here, but I'm trying to ask hard questions and propose ways forward. I really am trying to find places to build bridges and to build alliances and not walls. And I think that getting closer to people personally, getting to know people personally who are outside of your particular circle is really powerful. To learn what people know, what they need, even if you don't always agree. And primarily just to not assume that information flows only one direction. Okay, I'll put the hardest question up. Is bad science, like science that doesn't serve the public or that is misleading, is it science gone wrong, or is it science as usual? Is there something fundamental about the way that we're doing science today that needs to be reformed in some way, or are there a number of bad actors who are taking advantage of science? And really, those are sort of two sides of the same coin. I mean, in the sense that that if there are bad actors, we could reform science to try to stop them. And Collins says it's, well, I mentioned this sort of idea of when we abhor when there are bad actors, when we recognize when it is going wrong. So, and then, really, these are things that I'm sure people have thought about, but, is science more inclusive as a profession? Is it more inclusive in its conclusions? And I guess, is the broader direction of science, and specifically its questions more than its answers, simply what we make of it? And I'm very clear in that distinction, because I don't mean that its answers are what we make of it, but I do mean that we can choose to pursue inquiry in different directions, and we can choose to structure what we ask, even if we can't choose to structure what we find out. Thank you.
I've been involved with data collection in numerous ways that have been citizen called for. One was with lead in the soil, and the other was monitoring the river out here. But now I see a really important area for citizens or communities in having the skill to, you might say, cross-examine the experts, especially around infrastructure projects, and I'm thinking of the gas projects in Massachusetts, where there have been a lot of hearings, and the scientists or I would say the utility representatives have a lot of expertise.
Yeah.
And so there you have a great deal of information on their part. And then you have these limited opportunities for citizens to like raise their hand, like, wait a minute, aren't we getting too over-dependent on gas? But we don't have as equivalent ability to question the basis for how do you make decisions about these things and being able to influence the decisions that are made. So I see a gap there with whatever community ability, we need help in that way.
Yeah, there's certainly an asymmetry to it, and it's very difficult to have. For example, self-reporting is a common mechanism, in terms of regulations for producing knowledge about emissions or about potential pollution. But self-reporting is not blind. It's telling people what you did, and often, like in Louisiana, a lot of say smokestack emissions are based on estimates. They're not even actually based on empirical measurements that you perform yourself as an operator of a gas facility or a refinery. So it's very alarming because the standard of evidence is almost meaningless. It's like, I think we probably maybe emitted this much lead last night. We're next to a community, like a residential community. So that's very troubling. Part of this, the asymmetry is cost, as well as expertise. And I think the equipment to measure gas, if it's cheaper, it makes a lot of this easier. But it's not the whole equation, for sure. One example I wanted to share, actually, that I forgot was, so a lot of the community groups we've worked with in places affected by oil and gas will do grab sample measurements. So they take a bucket and they use a vacuum and they suck air into a gas a bag inside the bucket, and then they mail that entire bucket to a lab to get a certified test done of analysis of the contents. And what is nice about this is that it allows these community groups to choose based on their deep knowledge of the patterns, like, do the facilities typically emit at night? Do they emit at certain times, certain days of the week? Are there signals? Like, is there a flare-up that you see, or is there an alarm? Stuff like that. That enables them to structure when they take the samples in order to, sort of like catch the emission at the right moment. What's nice about it also is that it's a standardized test, so they can send it to different labs. They're sort of, in a sense, made it a service that these labs provide, as opposed to the people collecting the sample being the service part of it. So it's sort of inverting that in a nice way. And the thing that was really remarkable to me is that several of these communities that we've spoken with and worked with will actually not trust labs. One of them didn't trust in-state labs, and one of them just doesn't trust a lot of labs in general because they feel that there may be some of these labs do work for and accept money from oil and gas companies. And so what they did, which was really remarkable to me, is they faked samples. They made positive and negative control samples, and then they sent those to labs at a cost of hundreds of dollars per sample in order to test the labs. And only after confirming that these labs would correctly report different levels of pre-prepared positive and negative samples did they then use that lab for their own real sampling. And you can imagine that if community groups are already under-resourced and find it difficult to marshal the resources to do testing at all, that it's not trivial to spend all that money to establish trust. But I thought it was a really interesting example of science being done on scientists, and I think it's a positive. It's actually a positive thing,